We stopped here for a minute along Bishop Boulevard just to appreciate the beauty of the trees behind me. And what could be mathematical about a tree? Well, always mathematics starts with a question. And a simple question you might ask looking at a tree is, why do the branches get smaller as you go toward the top of the tree? It sort of seems like a dumb question, right? I mean, well, if they were big, the tree would fall over. Okay, that's fine, but maybe we could try to dig a little deeper and try to understand, how do they get smaller? How much smaller do they have to get? And what are some of the other reasons behind their getting smaller? Okay, and in fact, this is an interesting question because if you've been to the stop at the Cooper Centennial Fountain over in Turner Quad, the answer is kind of very much the same. So let's imagine we've got a hypothetical tree like the one below me. It's got a single trunk, and then it's got some branches that come off of that. And then of course those are gonna diverge into smaller branches, and then we'll have some tiny little branches up at the end, and there's so many of them I'm not gonna take time to draw them all. Now, as I said, there's lots of reasons why the branches have to get smaller, but what's the one that could possibly be related to a fountain? Well, what are the branches for? What happens in those branches? We know that there's photosynthesis in the leaves, and that's going to create nutrients for the plant. But there's other nutrients that it needs that it gets from the ground, right? So there's some nutrients down here, and there's some nutrients being created up here, and they've got to mix through the whole tree. They've got to be transported. The plant needs minerals from the ground to go up to the leaves to help them grow, and it needs the materials created by photosynthesis that are up here to get to the rest of the tree to help it grow. So you can think, in some sense, of the trunk and the branches as pipes. Well, thinking about them like pipes, the amount of stuff, nutrients that are flowing through a cross-section of the trunk has to match the amount that's flowing through cross-section of the branches, has to match the amount that's flowing through a cross-section even up higher in the branches. Well, if the total amount of material flowing through here is equal to the total amount of material flowing through here is equal to the total amount of material flowing through here, but yet there are more branches here and even more branches up here, the branches have to be smaller because otherwise there's not capacity enough in the trunk to handle all of the materials coming from the branches. And you can use this principle as a basic gauge to get a model of how thick the branches should be at each stage going up the tree. That matches pretty well. It's not exact, there are other things going on, but just like we saw in the stadium, this is an estimation of how a tree should go, and it comes out pretty well.